grids. So now we will start with the grid. So here we can create a bunch of types of grids. We can create hexagonal, radial, or square, triangle, or so. I'm going to start with square one because it's somehow most basic. When I put it, it creates something. So it has some default value, which is like very small down there in the center. It has the center point, which is in the plane here in the center point. For the size, we can control the size of the square. I can double click, I can say, I don't know, 15 and plug it here to the size. Just also to avoid everything here, I will create a new Rhino file. When I create, it will ask me, do you want to save the changes? I will say no. Small, yeah, small object, millimeters. I will change my view to shaded. Open only like the top view, so this is what we're working with now. Now we have our grid, and like the size of each rectangle of the grid can control it now, like for example 25. The extent X and the extent Y is like how many units do you want to create. Let's say also I want to create something like 25 is a little too much. Let's say 50, around 15 is okay. This way, if we want to, for example, in the Y direction to have more boxes, then we will use different slider. But for now, I want it big square. That's why it's 15 by 15. As output here, I can see that I have cells, which are like each one of these rectangles, and I have points, which are the base points of these rectangles. If I double click and grab a point container, which is this black X, and link this here, these are the points that we will be using. Now I will try to create a circle, like with this like orange circle command. This circle, I want to create it on each one of these points. Now it's creating me something, but it's also like very small. You can control the radius here. Let's say 15. Oh, maybe 15 is big. Something like 7, 8 is big. I want to show is the attractor, is the, like, if I have a point in somewhere and I want to like move this point, this point will be a Rhino point because I grabbed it from here. I created it from Rhino commands. And when I move the points, I want the circle or the radius of these circles to move and to change according to my point. To show an example, attractor method. In the end, we will have something similar to this, something like this. My main points will be the attractor and like will affect everything else. To do that, like the logic of it is to take this point, which is like one point I created in Rhino, and to calculate the distances between this point to each single one of these of the other like group of points. To do that, I will first call the point. I will link it between Rhino and Grasshopper. So I will insert another point container. I will set one point and choose my point till it becomes this green or red. This point that I had in Rhino is also connected in Grasshopper because it's showing as red or green when I select. The next step is take the distances. So I will grab this component here, the distances, and put it here. But the thing is, as we like reviewed before, if I call this point list thing that shows us the numbers of the list, it's from display under vector.
Display vector points list.
Mhm.
Okay, and that goes to the first one.
And from the size, I can also again put 5 or even bigger. I don't know.
Oops. You did 5 or 0.5? 5.
I made it like 10.
Okay. Oh, I think I'm just going to try. Okay.
So now this is gonna complicate things for me, because if I see these numbers, they always like start 0, 1 until 15, then again 0, 1 until 15, and so on. So each one of these sets is like a group of points by itself. It's not gonna work for me like that. To simplify that, like a very easy command here is just to right click here, and you can see here flatten. So if I flatten them, I can see that all of them now are just one single list, and that's like very easy to deal with. I can continue working with the distance component. I can link point A to be like the point that we grabbed from Rhino, and point B is this list of 255 points. And now it's giving me distances. Like if I grab panel, all of these values are distances between between this point to each one of these points. Some of them are low, like I don't know, 100 or so. Some of them are really high, like 800, 700, according to their position. What I want to do is I want to use these distances, like these numbers that I have, to put them inside, like to use them as radius of the circle. Let's just do that. If I plug these distances to the radius, what will happen? Well, a weird thing happened, which is like somehow similar to what we wanted. Like if we now choose or select this point on Rhino and change its place, everything, like all of these points, will also change. It's like creating 256 circles. Since we have here 256 points as they are numbered now, at the center of each one of these numbers, it's creating a circle. But the radius of the circle is differentiating according to the distance. This is what is happening. To like be more controllable, or like to make it better, like, controllable, these distances, I will start using these mathematical things that are here under math. So these are also like another boring, maybe like mathematical concepts, but they will do this work for us. What we like, first of all, what we want to do is to take bounds. So bounds, it takes some numbers and give you a domain. If I just link like all of these distances, which was like, as you saw, 159 was the nearest point, maybe 0 was the furthest. So now it will take all of these values and give us a domain. So it's telling us that this domain, or like all of these distances, range between 7 and 300 almost. All of these distances now, if I change, like these numbers will change. Now I have like about 5 and 400. So the nearest point here will be 5. This is the distance. And maybe the furthest one will be like 400. What I want to do, this domain to be rearranged, to be remapped, like,
Okay.
because if I have, let's say that this is the 5, the start 5 that we have, and let's say this is the 400, this, the end of the domain, which is like the nearest point and the furthest point. I want this domain that like I have here, I want it to be easier, to be like, for example, between 0 and 1. So the 5 will be mapping with 0, and 400 will be mapping with 1. So I'm gonna use this remap button here, and I'll put the values. I'm sorry, no, the values will be coming from the distances. So these are the distances I want them to shrink. For the remap, it's asking you, like, because also, like, as we said here, we have a source, the source numbers, which is like from 5 to 400, and a target, like, which is this, from 0 to 1. Like this is, I'm remapping the numbers from one shape to another, from one domain to another. So the source domain will be coming from this, from the one I take from bounds. Let's view that in the panel for now. If I link the original distances, you remember it was like these numbers between 300, 100, etc.
Yeah.
And if I call new panel here at the mapped value, the numbers that their values have changed, I will see that they are now all between 0 and 1. It kind of did what I want, so it mapped them. So this 0 was originally this one, which is what I meant before. So I wanted the 400 to be mapped with 1. So this is exactly what it did. So it took the biggest number and make it as 1, and the others accordingly. So if we have, for example, 200, it will be
0.5.
Remapped with 0.5 exactly.
Okay.
So this is it. This is what I did here with the remap. Plug these mapped number, the simplified numbers, to the radius instead of the previous one. Let me also like turn off the vision, maybe of everything before. Select everything other than the circle and hide. Now, like what we wanted to do, we did it. It worked, kinda. Because if I move my point here, I can see the circles and like everything is changing according to that. But still, my points are, my circles are really small. I can do like another improvement thing, which is to multiply by, I can say 10. I will take these numbers, the mapped ones and multiplying just to make them a little bit bigger. This but only what I want to do. So I will just double click, and if I say multiplication with the slider, I can say, well, I will get this map number here, the 12 here. So now what it's doing, it's just like if we grab a different panel, it's just multiplying everything by 12. So the one, now we have it 12, 0.9 is 11.95, etc. So it's just making these numbers a bit bigger. Now, these are the final numbers that I want to create with the radius. I linked this multiplication to the radius of the circles. Now, this is working fine. So if we just change the place of the point, the circles will kind of be afraid of it. And now we created, we're okay, satisfied with the final result, I can say. But we can also do more complex changes on these numbers. So instead of it being like very simple that it goes from like nearest to the furthest, I can do some I don't know, variation in the middle, make it look more interesting with only the changing the numbers. To do that, and it's also like a bit of a simple tool, it's not that complicated. I'm gonna double click and say graph mapper. It looks like this. So what it usually does, it just takes like an input and gives you an output. Very simple. This, if you can double click or right click, sorry, you can see here the graph types. I can say the Gaussian, I like it a lot. Let me link this here. It's not going to work fine because usually this works between 0 and 1. It works after this. So now it's not, it shouldn't be like coming from result after we multiplied by 12. It should be before. So let's link it from mapped. And the end of this grasshopper or the graph mapper will be multiplied, and this multiplication will go again into radius. So this is by changing also like the type of curvature here, that you can widen it, unwiden it. You have also like different types of graph types here. I think the conic will be very basic thing, I think. Not that much because it's only have 1 point. Maybe the Bezier, we can do something with that. There is Perlin. Perlin is basically a noise. It's like Perlin noise is something like mathematical concept. Just gonna keep going. Wow, this one's really cool. It's like heartbeats. One time I read about like people create like graphics like similar to this from music. So the music they create, or like some music, like the music beats or something like that, they use it, and it's like to show how music looks. All of this for now is like on a 2D surface. I can say, or on 2D plane. Next time we will see how to map again, like remap again with using this kind of concept, but instead of mapping numbers, we will map shapes.